I'm Anil Kumar sharing with you 7 questions based on application of derivatives, Unit 2. We have learned by now how to apply the power rule, product rule, quotient rule, and the chain rule. So we have 7 application questions where we will be dealing with tangents, normals, and some real life situations. I'd like you to copy these questions, solve them on your own, and then look into my solutions. I'll provide very short solutions since by now you know all the techniques to solve these questions, but my solutions can serve as a hint. The question here are like this. The first one is, show that the line 4x minus y plus 11 equals to 0 is tangent to the given curve. Second, find the slope of the tangent to the curve y equals to 3x minus x squared to the power of minus 2 at x equals to 2. Determine the quadratic equation if the graph passes through the point 2, 19 and it has horizontal tangent at minus 1, minus 8. The tangent to the curve y equals to x cubed minus 6x squared plus 8x at the point 3 minus 3 intersects the curve at another point B. Find the coordinates of the point B, right? So on the next page we have 3 more questions, which are, at what point on the graph of y equals to x squared minus 4x minus 5 is the tangent parallel to 2x minus y equals to 1? Then we have 2 application questions here. The concentration C of a drug in the blood T hours after the drug is taken orally is given by C of T equals to 5T divided by 2T squared plus 7. When does the concentration reach its maximum value? The radius of a circular juice blot on a piece of paper towel T seconds after it was first seen is modeled by R of T equals to 1 plus 2T divided by 1 plus T, where R is measured in centimeters. According to the model, will the radius ever reach 2 centimeters? Explain. And then you have to calculate few other parameters. The radius of the blot when it was first observed, the time at which the radius of the blot was 1.5 centimeters, and the rate of increase of the radius of the blot when the radius was 1.5 centimeters. So you can pause the video, copy the questions, and solve them. Here are my suggestions. So let's begin with the very first one, where we need to show that the line is tangent to the curve, right? So we are given the line which is 4x minus y plus 11 equals to 0. If I rearrange, I get y equals to 4x plus 11. So we know that slope of this line is indeed 4, right? So slope m is 4. Now if this line is tangent to the curve at a given point, that point is common to both, right? So what we are looking for is to prove 2 things. That is, we have to find common point. Is that okay? So we have to find a common point where slope is equal to 4. That's what we have to do, right? So what we can do here is we can find general equation of the slope for the given curve. We are given the curve y equals to 16 over x squared minus 1. The derivative will be, this is to the power of minus 2. So it will be minus 16 times 2. I should have written minus 2, but that's okay. X to the power of minus 3, which just comes here. Perfect. So at this point, this is the slope. And this slope should be equal to 4, right? So we can equate the slope. Slope is 4. So 4 should be equals to minus, this is 32, over x cubed. Cross multiply, so we get x cubed equals to minus 32 over 4, and that gives you minus 8. So x is cube root of minus 8. That gives you the value of x as equals to minus 2, correct? So if x is minus 2, we can find what y is. We can substitute here and find the value of y. So y equals to 16 over minus 2 square minus 1, and that is 16 over 4 minus 1, that is 4 minus 1, which is 3. So the point which is on the curve with slope of 4 is minus 2, 3, correct? So this is the point on the curve. This is on curve. So curve means this one. Now we have to only show that this point on the curve is also on the line. Perfect. So the equation is y equals to 4x plus 11. We can substitute the value of x, which is minus 2, in the given equation and say y equals to 4 times. If I substitute minus 2 here, then what is the y value? Let's calculate this. So we get 8 with a negative sign plus 11, and this is indeed 3. So on the line itself, the point which we have is also minus 2, 3. So we have a common point with the same slope. So that is how you can show that the equation of the line is tangent to the curve. Perfect. So I hope that is clear. Now let's move on to the next question. The next question here is the slope of the tangent to the given curve at 2, 1, 4. So we have only to find the slope of the tangent, not the equation. So let's say y is equals to 3x minus x squared to the power of minus 2. So we can apply the chain rule here. We get minus 2 times 3x minus x squared to the power of minus 3, right? Multiply by the derivative of inside function, which is 3 minus 2x, correct? Since we need to find the slope at x equals to 2, let's just plug in 2 here and calculate. So let me write it like this. We'll write minus 2, this cube in the denominator. So we have 3 times, we are substituting 2 for x, minus 2 squared, in everything squared, right, times 3 minus 2 times 2, right? So we can substitute these values. We get minus 2 over, here we have 3 times 2 is 6, minus 4 whole square times 3 minus 4 is minus 1. Right? So minus 2 minus 1 is plus 2. Let me write plus 2. And in the denominator, what we have here is 2 square, which is 4. And so we get slope of half. So the slope is equals to half, right? So that is how we can do this question. So let's move on. So now you can actually solve this question and check your answer. Now here is an interesting question. The question is, determine the quadratic equation if the graph passes through the point 219 and it has horizontal tangent at minus 1, minus 8. So let's begin by writing a general equation for quadratic function, which is y equals to ax squared plus bx plus c. Now actually we are given that there are these 2 points on the graph. So one point we can call this as A, it is 219, and the other one we can call as B, which is minus 1, minus 8, right? And we are also given that slope at x equals to minus 1 is 0. So that is the meaning of horizontal tangent at minus 1, minus 8. So that is the information given to us. So we can actually substitute these points in the given equation, get 2 equations, and the third one we can get from the derivative, correct? So we'll have 3 equations and we need to find A, B, and C, which we can do by substitution or elimination, solving simultaneous equations. Perfect. So that is the strategy. So let us substitute the first point 2 and 19, find one equation. So 19 is a y value. So we get 19 equals to 2 is your x value. So 2 square is 4, so we get 4a plus 2b plus c. Is it okay? So that is when we substitute a equals to 219, right? So we get one equation. Now we'll substitute minus 1 and get minus 8. So we have minus 8 equals to, when I substitute minus 1, square becomes positive. So we get a here, but this makes it negative b plus c, right? So this is when we substitute the point b, which is minus 1 minus 8. Now actually, from these two equations, we can eliminate c, as you can see, right? So let me call these equations as equation number 1 and 2, for example. Okay, let me use another ink here. So let's say this is equation 1, this is equation 2, and we do equation 1 take away equation 2, right? So if you do that, what do you get? 18 minus 8 means 18 plus 8, which is 27. And 4a minus a is 3a. 2b minus of minus b will give us plus 3b, and c minus c is 0. So we get this equation, and dividing by 3, we can write 9 equals to a plus b, right? So dividing by 3, we get 9 equals to a plus b. We'll call this as our equation number 3. Now let's move on and use the information that the slope of the tangent line is 0 at the given point where x is minus 1. So let's find the derivative. Y dash will be 2ax, right? 2ax plus b, and that is 0. Now this has to be 0 for x equals to 1. So we have m equals to 0 at the point b, which is minus 1 minus 8, correct? So substitute this to 0 at x equals to minus 1 gives us minus 2a plus b. So we can call this as our equation number 4, right? So that is how slowly we can actually solve for a, b, and c. Now, how do we eliminate? We can do equation 3, take away equation 4, so we can eliminate b. So we do equation 3, take away equation 4. What do we get? 9 minus 0 is 9, and a minus minus 2 is 3a. b minus b is 0. So from here, we get 9 divided by 3, the value of a. So we got one of our parameters, which is a, which should be equal to 3, right? So we get a equals to 3. Now, the others we can actually find by going backwards. So what we have got just now is that a is equal to 3. We do have an equation which relates a and b, which is equation number 3. We know a plus b is 9. Substituting 3 here, so 3 plus b equals to 9. That means b equals to 9 minus 3. So b is equals to 6, correct? So we know a and b now. So let me highlight these. B is also known to us. To find c, we could use one of our earlier equations. Equation number 2, let's take equation number 2, which is simpler, where minus 8 is equal to a minus b. A is 9, so I'm writing 9 here, minus b, which is 6, right? Plus c. So c could be 9 minus 6 is 3, so it is minus 8 equals to 3 plus c, or minus 8 minus 3 is c. So minus 11 is c. Is it okay? So you should check the calculations, and I hope you get the same result. So anyway, we got the values of a, b, and c, and so we can write down our answer that the equation which we're talking about should be a is 3, so it is 3x squared, b is 6, so we have plus 6x, and c is minus 11. I should have written y equals to all this. So that becomes the quadratic equation which is going to satisfy the given conditions. Perfect. So let's move on further to solve rest of the questions. The question here is, the tangent to the curve y equals to x cubed minus 6x squared plus 8x at the point 3 minus 3 intersects the curve at another point B. Find the coordinates of the other point. So let's find the equation of the tangent line, and then we will solve equation of the tangent line and the curve to find the other point, right? So we are given y equals to x cubed minus 6x squared plus 8x. So the derivative is 3x squared minus 12x plus 8. The point is x equals to 3, so let's put x equals to 3 here. So we get 3 times 3 squared minus 12 times 3 plus 8, and that is 9 times 3 is 27 minus 36 plus 8. So you can calculate this value, which is 27 minus 36 plus 8 is equal to minus 1. So that means the slope is minus 1. So what we have got here is slope m is minus 1, and the point, let's call this as P, as 3 minus 3, right? So we get equation of the line now. So we can say, what is the equation of the line? So let's say y equals to minus x plus b. To get the value of b, we'll substitute this point, minus 3 for y and 3 for x plus b. So taking it to the right, it gets cancelled off. So this gives b equals to 0, right? So once we know that b is 0, that means it is a direct proportion, and the line is with the slope minus 1, y equals to minus x, correct? So that becomes the equation of the line. So now it's question of finding the second point B. So we have the curve, which is y equals to x cubed minus 6x squared plus 8x, and we also have y equals to minus x. Substituting minus x for y, we get minus x equals to x cubed minus 6x squared plus 8. Bringing them together, we get 0 equals to x cubed minus, it's 8x, okay, minus 6x squared plus 8x plus x. So that is, we can take x common, this is 9 now, okay, x cubed minus 6x squared plus 9x. So taking x common, we get quadratic equation x squared minus 6x plus 9. Now, this is a perfect square with x minus 3 whole square, correct? So as expected, we do have a point with x equals to 3 value, which is from here. So the other value is clearly x equals to 0. So the points are at x equals to 0 and x equals to 3. So at 3, we know the value is minus 3. If I substitute 0 in my equation, then I get y equals to 0. And therefore, point B is 0, 0, right? So I hope that is absolutely clear. We are kind of rushing through this solution, since at this stage, you know fairly well how to solve such questions. So it just is a check for you for the correct solution. Okay, let's move on, and we are now going to take the 2 application questions. Well, here is another question based on tangents, and then we'll take the application questions. The question is, at what point on this graph is the tangent parallel to the given line, right? So these are standard questions. So let's take the slope of the given line. So the line given to us is 2x minus y equals to 1. Rearrange. So when you rearrange, you get 2x, taking y to that side, minus 1 equals to y, and that gives you slope m of 2. So the question is, at what point on this graph is this tangent parallel to this? That means on this line, which is y, on the curve y equals to x squared minus 4x minus 5, we want to find a point whose coordinates could be a and b. Let me write x and y now, where the slope m is 2. That's the whole thing. So let's find the derivative. Derivative is 2x minus 4. Equate this derivative to 2. So we have 2 equals to 2x minus 4. bring them together. So 6 equals to 2x, and that gives you x as 6 divided by 2, which is 3. Whenever we say find the point, that means you need coordinates. So substitute 3 back to the equation. So get y equals to 3 squared minus 4 times 3 minus 5, and that is 9 minus 12 minus 5, and then let's figure this out. So it is 9 minus 5 minus 12 equals to minus 8. So the coordinates of the point are 3 minus 8. Perfect. So that is how you can find at what point on this graph is the tangent parallel to the given line, correct? So that is the point. Okay. So now let us take the application questions. The first one here is the concentration C of a drug in the blood T hours after the drug is taken orally is given by this function. When does the concentration reach its maximum, right? So whenever you take a drug, it starts acting slowly, but somewhere we may have a maximum, right, effect. So wherever there is a maximum, we expect a turning point, and slope at this point is going to be 0. So that is the strategy which we are going to apply to get the solution of the given question. So we are given the function C of t, concentration is 5t over 2t squared plus 7. So let's find the derivative of this function, which is equal to, applying the quotient rule, we have 2t squared plus 7 whole square. Derivative of 5t is 5, so 5 times 2t squared plus 7, take away derivative of this function times 5t, or we can write 5t times derivative of this function, which is 4t, right? Now, the derivative should be 0, so we'll equate this to 0 to find t. That's the whole idea. So let's do that, and that really means that the numerator should be 0, correct? So that means that 5 times 2t squared plus 7 minus, when you multiply this, you get 20t squared, should be equal to 0. Is that okay? So that means the numerator is 0, right? So this means numerator should be 0. Perfect. So it's a question of solving for t. Let's open the bracket. We get 10t squared minus 35 minus 20t squared equals to 0. Now, taking this on the right side, what we get here is, I'm sorry, this is plus 7 times 5. So we can 10t squared minus 20t squared is minus 10t. So we can write, taking it on the right side, we can take 10t squared equals to 35, or we can find the value of t from here. Let's do it on the right side now. Okay. So that means that t squared is equals to 35 divided by 10, which is 3.5, or t is square root of 3.5. Now we are going to take only the positive value, since in such cases t is normally greater than or equal to 0, right? Time after it has been taken, that is t. So square root of 3.5 is equal to, in decimals, is equal to 1.87, right? Hours. So t is in hours, so many hours. So that is the solution for the given question. So I hope the concept is absolutely clear. The idea is slowly the drug will make an effect, and after so many hours, which you could also convert into hours and minutes, multiplying 0.87 by 60, right? 0.87 times 60 will give you a number of minutes. So around 52 minutes, right? So you could also write 1 hour 52 minutes. After that much of time, the effect will be maximum, right? So almost 2 hours. Now let's take up the last question of our series. I hope you find it interesting and useful. So copy this question if you haven't done so. Try to answer it on your own and then look into my solution. The question here is, The radius of a circular juice blot on a piece of paper towel t seconds after it was first seen is modeled by r of t equals to 1 plus 2t divided by 1 plus t, where r is measured in centimeters. According to the model, will the radius ever reach 2 centimeters? So the model here is, let me answer this question first. R of t equals to 1 plus 2t over 1 plus t, right? So will it ever reach 2 centimeters? Now, if you recall, we have done rational functions, horizontal asymptotes, and the equation for horizontal asymptote is ratio of the leading coefficient, so it is 2. So the function really approaches value 2, it is never there. Anyway, another way to do it is that we can take t common, we can also use limits, right, basically. So basically we're trying to see limit of this function as t approaches infinity. Will it ever reach 2, right? That's what we're trying to do. So we can take t common. So if I take t common, I get 1 over t plus 2 over t common, I get 1 over t plus 1, correct? If t is approaching a large value, then 1 over t is approaching 0. So we can say the limit when t is approaching a very large value, then we can cancel this first. And then we can say this approaches 0, right? So now we say this value 1 over t approaches 0, correct? So what are we left with? We are left with 2 over 1, correct? So which is we are approaching 2, but we are not quite there, correct? So that is the reason. So it says, according to the model, will the radius ever reach 2 centimeters? The answer is never, or it will not reach. So no, it will only approach. It will approach 2 centimeters, correct? So that's how you could answer it. Part A is the radius of the bolt when it was first observed. So you have to calculate all these things. First observed means at t equals to 0. If I substitute t 0, I get the value as r of 0 equals 2. Substituting 0 is 1 over 1. So it is 1 centimeters. Is it okay? So, and part B is the time at which that means we have to rearrange and solve for time. So let me write this as part A, and now part B is 1.5 becomes the radius. Let me write 1.5 here. We get 1 plus 2t over 1 plus t. So you can cross multiply and solve. So we have 1.5 times 1 plus t equals to 1 plus 2t. So open the bracket. So we get 1.5 plus 1.5t equals to 1 plus 2t. Taking this to the right, we have 1.5 minus 1 equals to 2t minus 1.5t, which is 0.5 equals to 0.5t. So t is equals to 1, right? So after 1, and 1 is what units? The units here are t is in seconds, correct? So t is in seconds. So after t equals to 1 second, the radius is going to be 1.5 centimeters, correct? So that is how you'll do part B. Part C is the rate of increase of radius of the bolt blot. So the part C is the rate of increase of the radius of the blot when the radius is 1.5. So now you have to find the derivative, perfect, of the function, and then substitute time as 1 second, correct? So we know time is 1 second for this situation. So let's find the derivative. We can apply the quotient rule. So r of t is equal to derivative. So denominator is 1 plus t whole square. Derivative of 2 from the numerator times 1 plus t. Take away derivative of denominator is 1. So it is 1 plus 2t, right? So you could solve this also, or just substitute the rate of change at t equals to 1. So I'll substitute 1 here. right? I'll just substitute 1 here and then calculate. So we have 2 times 1 plus, let me write 1 for t, right? Okay, minus 1, actually that will cancel also, anyway, whatever. So 1 plus, if I write this 2, and this is 1 plus 1 whole square. So what do we get? So 1 plus 1 is 2, 2 times 2 is 4, we get 4. Here we have 1 plus 2 is 3, minus 3, over 1 plus 1 is 2, 2 square is 4, right? So it is 1 over 4. So radius is increasing at the rate of 1 over 4. The units are centimeters per second. Is it okay? So that becomes your part C. So the answer is it is increasing at the rate of 1 over 4 centimeters per second. Correct? So I hope you have learned a lot with this quick series on application and thinking questions based on derivatives, Unit 2. Feel free to share your comments and views, and if you like and subscribe to my videos, that would be great. And keep sharing your test papers and assignments. Thank you, and all the best.